Thank you very much for joining in. Today we'll be looking at this book, Basic Concepts in Nuclear Physics. Theory, theoretical analysis, and also experimental investigative side of it, as well as a few applications. Quite a few new applications have been introduced by PhD students discussing their posters and conclusions of their theses. So it's a Spanish collaboration held by a number of sponsors. It was held in 2015 and published, and this book collection of the exegesis of the findings of those graduates, postgraduates, and PhD students was summarized, finalized, and published in 2016. So it took about a year for it to be prepared and published. So it's Basic Concepts in Nuclear Physics, Theory, Experiments, and Applications. Don't be fooled by it, because it's not. It's anything but basic. It's to do with advanced techniques and the theoretical explanation of those advanced techniques, as well as the experimental investigations carried out at PhD level. As well as how these experimental investigations can be used as applications for non-invasive therapy. That's what they mean by basic concepts in nuclear physics, because it's all of these topics in this book are quite new. They're very nuanced. They're very hyper strategized for advanced innovative thinking out of the box. So yeah, we start off with the preface. Took place in mid of 2015 and was published in 2016. Spanish scientists, collected their research or sponsored by these Spanish institutions. Usually it's Italians, but in this case they were Spanish. Italians are dominating the physics department of many universities in England, which is a very good thing. A lot of graduates and PhDs have come from Italy to populate the university departments of England and pour through their research. It has its positives and negatives. So it has about, 3 sections. The first section is quite boring. It's about hadron therapy, gamma ray spectroscopy, which we all know about, and then density differential calculations of different nuclei and neutrinos in nuclear physics. It starts off but the gradient gets very steep in section 2, which is the largest, and the most dense when it comes to with respect to investigative techniques. And it's very nice. I like it. I like section 2 more than section 3, because in section 2 they've introduced diamond detectors for neutron therapy, and they've also spoken of lead dating, whilst the usual standard is always argon or potassium or carbon dating. So they've introduced the benefits of lead dating, right? And then what they've done now is that they've also the students Anna's Deb and Mikhail Wada, they did a study on fission fragmentation. So that's very nice. Like, you get a wide variety, broad spectrum approach to different techniques and current affairs, contemporaneous research carried on in nuclear physics. Right, so the part 3 is all about super heavy nuclei, deuterium, tritium, heavy water, and then it's computer modeling, which is my least favorite. Followed by a bit of detector studies of heavy ion reactions. Nothing new, time of flight, mass spectrometry has been doing it for a long while. So studying heavy ion reactions is nothing new. So yeah, and that's pretty much it. I don't know what the last project is all about. A proposal for 72.75 megahertz radio frequency. I don't know about this. I haven't read about it, but I don't know how useful it may be. And noise analysis, the use of silicon, and then Higgs exclusion. And at the third topic is quite fantastical. I'm not, I wouldn't waste my time on the third from the third last. But the Monte Carlo studies and a Markov chain, that's going to be very useful for people who are doing computing and radiation physics, because it gives you an insight into the AI and telemetry analysis, telemetry techniques. So yeah, Monte Carlo is a very statistical Bayesian, and yeah, I'd like to go through it just a little bit. But yeah, that's pretty much it. So this book is around 55 quid, I think, £55, Spanish in nature, published in 2016, and yeah. So if we go through the book now, we can see that you can see the email addresses of all these scientists. You can email them for further information pertaining to their research. And now the papers begin. Colorful diagrams, I like that. The quantum chromodynamics representation is very nice. I'm glad they've not made it monotonous. They've kept the color coding, which I love. I love color coding. So we start off with simple formulae, simple diagrammatic representations, and it kind of convolutes very quickly into second order differential equations and quantum mathematics, which is not too difficult. I like the fact that they are explaining the calculation step by step, and that's what I prefer for it to be. So these formulae are very nice. L of x, and then momentum summation calculations, and yeah, there's ample explanation of the mathematical procedures, and it's very nice. That's what I like. There's a good balance of theory and practicality. The diagrams are drawn very nicely. The graphs are clear. The error bars, statistical etiquette has been kept. Nice diagrams in all sections. H2O, D2O, 320. And this study is about effective ionizing radiation on DNA, which is quite cliche. Like, it's very average, like hadron therapy. So hadron therapy, in comparison to photon electron beams, electrons are fermions, so they're not hadrons. The hadrons are protons and heavy ions, so they are being used to target tumorigenesis, which is good because they have their own ionization characteristics. And over the last few years, proton therapy has been dominating a lot of hospitals in England. They're moving away from fermion therapy to hadron therapy, which is alright. Heavy charged particles have low internal ionization potential, and they have a higher targeting specificity. So yeah, I guess if it's good, then it's good. Nice colourful diagrams helps me understand different components of the diagram much better, and I'm sure people with other ASD, disabilities, dyscalculia, dyspraxia, dyslexia would find it very, very helpful. So that's nice. It's a very well organised radiation physics paper. It's a summary. What you need to realize is these papers are summaries of the thesis of those PhD students. So these aren't full papers. These are summaries. And now we move over to gamma ray. So gamma ray papers, Bragg peak, this and that. Computer modeling diagrams are very nice. False color diagrams are very good, very useful, very nice. Thank you. And yeah, and then there's the gantry. Good. Very nice, very nice. So this is what this book is all about. I hope you enjoyed it. And yeah, that's what it is. Now let me move over to the last part, which is all about positron emission tomography. No, the last paper was about Monte Carlo simulation. So this is they're using positron emission tomography to test their Monte Carlo simulation, which is alright. You can use any. You can use scintigraphy or fluorimetry. You could use different procedures, or maybe DEXA scan to carry out test your Monte Carlo simulation. So you can use any technique from amongst the ionizing radiation cohort. So yeah, that's pretty much it really. Thank you very much. And I like this circuitry diagram. It has the capacitor there, the resistor, and the ionizer, the induction coil, followed by a reverse bias diode. That's nice. That's good. Thank you very much. That's nice. Computer simulation experimental results. See, I'm not a fan of computer simulation. I prefer to read and study actual real experimental investigation conclusions, because that's what real life, real time analysis is all about. Computer modeling is extremely biased, and it depends on what data you feed in there, what variables, what parameters you set. The computer modeling studies are extremely double bound by the conditional parametrics you impose upon them. So I'm not a fan of computer studies, never have been. Thank you very much. I hope you found this video useful. Please do talk to me about it. And yeah, thank you very much. Cheers.